In this system of equations problems, I know that 3x plus 2y equals 2, and I know that y plus 8 equals 3x. As you can see, neither of the equations read x equals something or y equals something, which is a change I'm going to have to make before I begin. I can choose which equation I want to read x equals something or y equals something. I'm going to choose the second equation. Furthermore, I'm going to choose to get y by itself because, as you can see, there's no number in front of it. In all the other cases of the variables, there's a number in front of them. A 3 in front of this x, a 2 in front of that y, and a 3 in front of that x. So my only choice is to really get this y by itself, which means I'm going to need to move that 8 to the right side of the equal sign. As you can see, there's an addition sign in front of it, so I'm going to have to subtract 8 from each side of the equal sign. When I subtract 8 from each side, it actually doesn't do anything in that it doesn't combine with the 3x. They remain separate entities, and the equation reads y equals 3x minus 8. Now, since that came from the second equation, I'm going to have to plug it back into the first equation where y is. So, this first equation is now going to get changed into 3x plus 2, parentheses, 3x minus 8, close parentheses, equals 2. Now, as you can see, once again, subtraction has returned to this problem. So I now want to take a moment to change subtraction into adding the opposite. So the problem is going to be changed into 3x plus 2 times 3x plus negative 8 equals 2, which will avoid a lot of problems later on down the line. Now I'm going to go ahead and use the distributive property with these parentheses, and I'm going to distribute the 2 through. Remember, the 2 has to go through to the 3x and the negative 8. 2 times 3x is 6x. 2 times negative 8 is negative 16. The 3x and the 2 stay in the front and back respectively. Now I'm going to start combining like terms. I need to combine the 3x and the 6x, and when I put those two together, they're going to make 9x. So the resulting equation is 9x plus negative 16 equals 2. We strongly desire to move lonesome numbers or constants to the right side of the equal sign. So this 16 is going to have to get joined with the 2 at this point. As you can see, there's an addition sign in front of the negative 16, which means I'm going to have to subtract negative 16 from both sides of the equal sign. But we know from elementary mathematics that subtracting a negative is the same as adding in actuality. So I'm really adding 16 to both sides of the equal sign. And the result is now 9x equals 18. I can now find x simply by dividing both sides of the equal sign by 9, and I quickly find that x equals 2. Now I'm going to return to my original two equations. I can now at this point pick which equation I want to work with. I can choose to work with 3x plus 2y equals 2, or I can work with y plus 8 equals 3x. Let's choose y plus 8 equals 3x. We learned just a moment ago that x is equal to 2. So at this point, I want to go ahead and change x into 2. So the problem now reads y plus 8 equals 3 times 2. Or in other words, y plus 8 equals 6. To get y by itself, I of course simply need to subtract 8 from both sides of the equal sign. And by doing that, I obtain a result of y equals negative 2, which is the other half of my solution. So my solution to this problem is that x equals 2 and y equals negative 2, or I can express my solution using the ordered pair 2, negative 2.